So here are some basic rules for integration. The first one is the integral of k with respect to x, assuming k is a constant, is just kx plus c. And this makes sense because the derivative of kx plus c will just be k, and you just think about it in reverse. And the second rule is the integral of x to the power of n, assuming n is a number, with respect to x is equal to x to the n plus 1 all over n plus 1 plus c. And we already kind of talked about this in our video of the introduction to indefinite integrals. But yeah, this is just like a reverse of the power rule for derivatives. And the third rule is the integral of e to the x dx is equal to e to the x plus c. And again, if you know that the derivative of e to the x is e to the x, then this should make sense. And the fourth rule is the integral of 1 over x with respect to x is equal to ln of the absolute value of x plus c. And you probably know that the derivative of ln x is equal to 1 over x. And the reason why we put these absolute value signs around the x is because the domain of 1 over x is all real numbers except for 0, and the domain of ln of x is all positive numbers. So by putting this absolute value, we're extending the domain of ln x to be negative as well, to fit 1 over x. And here are 3 more rules. The integral of cosine x with respect to x is sine x plus c. The integral of sine x with respect to x is negative cosine x plus c. And the integral of secant squared x with respect to x is tan x plus c. And you should probably already know these just by knowing what the derivative of sine, cosine, and tangent are. You just think about it in reverse for integrals. So here's an example problem that involves some of these rules. Let's say we want to find the integral of 3 times e to the x minus 1 over x with respect to x. And what we can do is split this into 2. First focus on the 3 times e to the x and 1 over x. So 3 times e to the x, as we learned, we can take the 3 out. So 3 times integral of e to the x dx is equivalent to this part. And again, e to the x, the integral of that is e to the x plus c. So the integral of 3 times e to the x is going to be 3 times e to the x plus c. Now let's focus on the minus 1 over x. We already know that the integral of 1 over x is just going to be ln absolute value of x, but since it's negative, we add a negative sign, and our plus c, of course. And then when we combine these, we get our answer of 3 times e to the x minus ln x, or ln absolute value of x, plus c. And that's the final answer. And again, you don't combine these plus c's. You just write one c at the end because it's not something that you're supposed to treat as a variable. It's something that you add at the end of your integral. Now, let's do a practice problem. If you think you can do this one, then pause the video and try it. This problem has to find the integral of square root of x plus 3 with respect to x. And again, we can kind of split this into 2 parts, think about them separately. First, let's focus on the square root of x. And this might be a little confusing, but if you notice, we can rewrite the square root of x as x to the power of 1/2. And then we can just use the power rule we got, so it's just going to be x to the power of 3 over 2, because 1/2 plus 1 over 1/2 plus 1, so 3 over 2, which is equal to 2 times x to the power of 3 over 2 over 3. And again, this 3, as we learned in our rule, is just going to be 3x plus c. And this should also have a plus c, but we can ignore it for now. And then we combine these, so 2x 3 over 2 over 3 plus 3x plus c. And that's our final answer. Now, let's do another practice problem. If you think you can do this one, then pause the video and do it. This one says, find the integral of secant squared x plus 2 times sine x with respect to x. And as always, we can focus on this first part first, secant squared of x. This is just going to be tan x, as we learned in the beginning, and 2 sine x. Well, we know that the integral of sine x is negative cosine x, and we can take the 2 out and just put it back in because it's just a constant. And then don't forget tad plus c. And this is just our final answer. So secant squared x becomes tan x, sine x becomes cosine x, and the 2 stays, and there's a negative because sine becomes negative cosine, plus c. And that's our final answer. Now, let's do one last practice problem. If you think you can do this one, pause the video and try it. This one asks to find the integral of 2 over x minus cosine x with respect to x. And as always, let's just focus on the 2 over x first. So 2 over x, this might be a little confusing to integrate at first, but you can notice that you can rewrite it as 2 times 1 over x, and we already know how to deal with these constants at the beginning, and we already know what the integral of 1 over x is. So this will just be 2 times ln of the absolute value of x, and now let's focus on this cosine of x. The integral of that is just sine x, and now if we put everything together, we get 2 times ln of the square root of x minus sine x plus c. And that is our final answer. So everything that I explained in this video and all the problems that I went through is to teach you everything that you need to know about some basic integration rules. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.